In the 21st century, humanity faces a paradox. Our cities' symbols of progress are also epicenters of consumption, waste, and vulnerability. But what if a city could think, sense, and adapt like a living organism? From the moment humans gathered around rivers like the Nile, Tigris, and Indus, water-shaped civilization, cities rose, where water flowed lifelines carved through deserts and plains. Yet today, those same rivers struggle to feed the megacities built upon them. In just a century, we've gone from drawing buckets from wells to managing water networks, stretching thousands of kilometers, invisible veins, beneath concrete jungles. Now, as the planet urbanizes faster than ever, a new question emerges. Can technology restore balance between cities and nature? This is the dawn of the smart city. A smart city isn't merely digital, it's aware. It listens through millions of sensors to every drop, every leak, every heartbeat of its infrastructure. In Barcelona, thousands of IoT devices monitor streetlights, humidity, and water flow in real time. In Singapore, rainfall patterns and reservoir levels feed into a national AI network that predicts water scarcity before it happens. And in Copenhagen, the entire city is mapped as a digital twin, a living simulation that learns, reacts, and plans every second. Water isn't just a utility. It's the pulse of every smart city. Every shower, every garden hose, every drop running down a street drain forms part of a complex web of data. IoT meters detect pressure fluctuations, micro leaks, and contamination risks before a human eye could ever see them. For centuries, we managed water blindly. We built pipes and prayed they wouldn't burst. Today, cities are learning to see their water in ones and zeros. In Tokyo, engineers have integrated ultrasonic sensors inside water mains, listening for faint echoes that reveal tiny cracks. In Los Angeles, satellite data tracks changes in soil moisture to detect underground pipe failures. Every pixel, every frequency, every signal and other neuron in the city's mind. What makes a smart city truly smart isn't the technology alone, it's the integration. Traffic data informs drainage systems. Weather forecasts adjust irrigation. Electric grids talk to pumping stations. The result? Efficiency once thought impossible. London reduced its water leakage by nearly 40% after deploying real-time pressure management systems. Dubai uses predictive analytics to match desalination output with demand peaks, saving millions of gallons daily. But there's a paradox in the rise of smart cities. The more digital our world becomes, the more we depend on invisible systems and the data they hold. What happens when that data fails? Or worse, when it's hacked? If water is life, then data is its DNA. And when that DNA is corrupted, cities can bleed. In 2021, a water treatment facility in Florida was nearly poisoned when hackers breached its control system remotely. The attack was contained, but it was a warning. Connectivity brings intelligence and vulnerability. Thus, the evolution of smart cities isn't just about algorithms, it's about resilience. The architects of the next generation aren't only engineers, they're digital ecologists. They design cities that respond, heal, and learn. In Toronto's Quayside project, adaptive pavements filter stormwater runoff. In Seoul, AI-driven flood barriers rise automatically during monsoon seasons. In Amsterdam, community dashboards let citizens track their neighborhood's water consumption in real time. In the past, we designed cities to conquer nature. Now, we design them to coexist. The vision of a truly smart city is almost biological. Pipes become arteries, data centers act as brains. Sensors the nerves, a networked ecosystem, breathing, sensing, learning powered not just by code, but by conscience. Imagine a city that never sleeps because it listens. A city that learns from storms, adapts to droughts, and treasures every drop as a living memory. That city is coming, and its story begins with us. Cities are often seen as vertical landscapes, with skyscrapers reaching for the sky. But the true marvel of the modern city lies hidden beneath the asphalt, under the feet of millions. It's an invisible web, a network that never sleeps, listening to every pulse of the urban heart. Under every street, a hidden labyrinth of pipes, tunnels, and sensors forms the city's circulatory and nervous systems. Miles of water mains twist through the darkness. Here, in this living architecture of metal and concrete, a revolution is taking place. IoT sensors have replaced traditional human inspection. They detect vibrations, measure flow rates, sense pressure changes, and whisper their findings into the city's digital brain. This isn't science fiction. In Seoul, over 20,000 smart meters monitor water quality in real time. In Tokyo, fiber optic cables detect leaks by sensing minute temperature shifts. And in Copenhagen, sensors beneath storm drains can forecast flooding hours before the first drop of rain even falls. For centuries, cities reacted to disaster. Now they anticipate it. Each sensor, some no bigger than a coin, has a mission. Some listen for ultrasonic echoes bouncing through water pipes. Others measure turbidity, temperature, and chemical composition. Together, they create a living nervous system for the city. Every time a drop of water flows, it leaves behind a digital signature, a unique pattern. Pressure spikes, microleaks, even contamination all become data points that artificial intelligence reads like vital signs. If pressure suddenly dips on 9th Avenue, the AI triangulates the location. Is it a leak? Is it illegal tapping? A maintenance drone is dispatched before significant water loss even begins. The city no longer waits for chaos. It senses imbalance and heals itself. Imagine this. A single droplet begins its journey from a treatment plant miles away. It moves through valves, filters, and meters, each one equipped with sensors. The droplet's passage generates thousands of data points, creating a rhythm. a heartbeat. These readings merge on real-time dashboards in control centers. They're human engineers, aided by powerful algorithms. Monitor the city's water as if it were a patient under intensive care. Every bubble, every vibration, every unseen pulse is recorded and analyzed. In Dubai, these AI-driven dashboards reduced pipeline failures by an astonishing 70% in a single year. In Singapore, predictive analytics allow the government to seamlessly balance water distribution between reservoirs, desalination plants, and recycled sources. Water is no longer invisible. It speaks through numbers, through code, through light. These smart systems don't replace people. They extend their capabilities. Engineers once walked the streets, pressing metal rods to the ground to listen for leaks. Now, they command fleets of autonomous robots, hovering drones, and sensor arrays that map the unseen world beneath their feet. But the challenge isn't just building these systems, it's managing the flood of data. Millions of signals per second, petabytes of measurements streaming non-stop. How do you distinguish noise from meaning? This is where machine learning comes in. AI models are trained to recognize anomalies, predict failures, and optimize flow. These digital minds evolve over time, learning the unique language of the city's water network. The smartest cities aren't those that collect the most data, but those that understand it. Far beneath the bustling streets, these silent protectors prevent crises that would have once crippled entire districts. A rising pressure warns of a blockage. A slight drop in chlorine hints at contamination. A sudden echo in a pipe signals a structural crack. The system sends an alert before humans even notice a problem. This is the power of predictive maintenance, not reaction, but foresight. In Madrid, this technology saved millions of liters of water annually. In Melbourne, it prevented a citywide outage by detecting a single weak valve deep underground. Every city has bones, muscles, and blood, but now, for the first time, it also has nerves, and they can feel. With each passing year, this data web grows more intelligent. Sensors are evolving from passive observers to active participants. They talk to one another through machine-to-machine communication. When rainfall sensors predict flooding, they automatically alert pump systems downstream. When water consumption spikes in one neighborhood, desalination plants upstream increase their output. The entire city becomes a self-regulating organism guided by a digital intuition. For the first time in history, our cities are no longer blind. They can sense, they can adapt, they can feel. This is the silent revolution happening right beneath our feet. This is the heartbeat of tomorrow's cities. What if a city could think? What if it could learn from the past, predict the future, and make decisions all in real time? For centuries, human engineers have tried to predict water, its flow, its scarcity, its chaos. But water, like humanity, refuses to obey simple equations. It is alive, unpredictable, poetic. And now, for the first time, artificial intelligence is beginning to understand its rhythm. AI in water management didn't start with grand visions. It began with data. Millions of readings per hour from pumps, pressure gauges, rainfall sensors, and consumption meters. Too much for any human team to process. So the city built a new kind of mind. Every sensor whisper became a neuron, every leak detection a memory, every rainfall prediction a pulse. Slowly, the machine began to see the city not as streets and pipes, but as patterns and probabilities. This isn't science fiction. It's already happening in Singapore, in Dubai, in Tokyo. In Singapore, the smart water grid AI predicts demand hours in advance and redistributes flow autonomously. In Tokyo, rainfall and consumption models are merged with satellite data, helping balance water across an entire metropolis. And in Los Angeles, deep learning models forecast pipe bursts with 80% accuracy weeks before they occur. To predict water is to predict life itself. Chaotic, nonlinear, ever-changing AI systems analyze decades of weather archives, soil moisture records, and consumption trends. They don't just respond. They anticipate. In Cape Town, predictive models helped the city avert day zero when taps were expected to run dry. By analyzing citizen behavior, reservoir levels, and evaporation rates, AI adjusted water allocation in real time. A city that sees the storm before the clouds form, that's not prophecy. That's data, learning to dream. The systems run millions of simulations daily. Every possible rainfall pattern, every burst pipe scenario, every street corner where water might pool during the next monsoon. The city no longer fears chaos, it prepares for it. Inside climate control rooms, engineers now sit beside algorithms. Together, they form a new alliance. Human intuition fused with machine precision. These AEs are self-learning guardians. They detect when reservoirs drop below safe thresholds. They divert water from underused districts to those in need. They even learn the personality of a city, its unique consumption rhythms, cultural habits, and seasonal moods. Every city breathes differently. AI doesn't just see data, it learns the pulse. In London, the system knows that Mondays mean morning showers spike after weekend rest. In Dubai, Ramadan nights bring water surges at unexpected hours. In New York, the algorithm senses when heat waves trigger simultaneous air conditioning and water cooling demands. Each dataset refines the city's neural pathways until it begins to think like its people. Water management isn't limited to pipes anymore. It's planetary. AI now ingests satellite imagery, radar feedback, and atmospheric chemistry to anticipate rainfall with precision once deemed impossible. In Jakarta, AI models predict floods up to 5 days in advance, enough time to clear storm drains and deploy relief crews. In Venice, adaptive gate systems rise automatically when tides approach danger levels. And in California, algorithms anticipate drought years and optimize reservoir releases months before shortages occur. The clouds speak in patterns, and for the first time, we can understand their language. But intelligence demands trust. A city guided by algorithms must place its faith in invisible logic. What happens when the data is wrong? When bias enters the model? When code misunderstands chaos? In one experiment, an AI overestimated drought severity, diverting water unnecessarily and creating shortages elsewhere. In another, cyber attacks attempted to manipulate flow data for ransom. As cities grow smarter, their vulnerabilities grow too. Intelligence without ethics is just automation. Wisdom requires empathy. Thus, the new frontier isn't simply machine learning, it's machine morality. Designing systems that are transparent, explainable, and human-aligned. Engineers call it trustworthy AI. Hydrologists call it survival. At its best, AI doesn't control cities. It collaborates with them. It listens to the rhythm of water, not to command it, but to coexist with it. In Seoul, an AI named AQUA mind dynamically balances river inflow and urban drainage, reducing flood risk by 60%. In Melbourne, HydroNet uses reinforcement learning to optimize stormwater reuse. And in Amsterdam, digital twins allow engineers to test water strategies in virtual replicas before applying them in real life. The future city is not built of steel and glass alone. It's built of code, consciousness, and care. A city that learns from water becomes alive. From chaos to code, from drought to design, this is the mind of tomorrow's city. Subscribe to HydroVerse and witness intelligence flow. Every civilization has been built beside water, and every civilization has been broken by it. From ancient Mesopotamia to modern Mumbai, water has always been both the giver and the destroyer. Now, in the age of climate crisis, our cities face the ultimate test. Can we build infrastructure that adapts, bends, and survives? For centuries, engineers believed resilience meant strength. We built bigger dams, deeper canals, and higher walls. We tried to dominate water. But in the 21st century, strength has a new meaning. Because no wall is high enough to stop the ocean from rising. No pipe is wide enough to capture a century's worth of storms. As global temperatures rise, urban rainfall patterns are changing dramatically. Storms grow shorter but far more intense. This is the paradox of climate adaptation. The future city must be strong enough to endure, yet flexible enough to yield. Now, we must learn to dance with it. Enter a new philosophy, nature-based design. The most resilient infrastructure is not made of steel, it breathes. Instead of concrete walls, we build wetlands. Instead of drains, we design living rivers. In Copenhagen, green roofs capture 80% of annual rainfall before it even hits the sewer system. In Singapore, entire districts are turning storm drains into landscaped parks that flood intentionally, acting like giant urban sponges. And in New York, the Big U project wraps Lower Manhattan in a protective belt of parks that both beautify and defend. These are adaptive infrastructures, systems designed not to resist water, but to collaborate with it. When the storm comes, the city doesn't panic. It breathes in, absorbs, and lets go. But what if the city itself could move? In the Netherlands, where a quarter of the land lies below sea level, architects are building floating neighborhoods. Entire homes rise and fall with the tides anchored to flexible moorings. Schools, parks, even power stations drift together like islands of resilience. They don't fight the water. They live with it. In Jakarta, they're experimenting with amphibious housing that rests on land during dry seasons and lifts during floods. But in Bangladesh, floating hospitals and schools travel through monsoon waters to reach isolated communities. This is more than engineering its hydraulic empathy. A city learning not to defy water, but to mirror its grace. Today, resilience is also measured in gigabytes. AI models now simulate how every rainfall will move through a city, predicting which intersections will flood and which bridges will strain. Maintenance drones scan pipelines with thermal imaging, and smart water gates can form a digital shield against typhoons. In Seoul, a system called HydroVerse monitors underground pipes for microfractures invisible to the human eye. In Miami, predictive tide sensors link directly to stormwater pumps, activating them before the surge even reaches the shore. The modern city is alive and aware of its vulnerabilities, the fusion of data and design that is the new resilience. But resilience is not just physical, it's psychological. When disaster hits, what breaks first is not the pipe, it's the system of trust. Cities are now building social resilience networks, local communities trained to manage crises together. Apps crowdsource flood data from citizens in real time, mapping safe evacuation routes. Planners design cool zones and water hubs where people can gather during heat waves. Because the true infrastructure of resilience is people. A city that remembers its pain learns faster than one that forgets. Every flood leaves behind data. Every drought writes a new algorithm. And slowly, the city evolves, not through walls, but through wisdom. Resilience is not resistance. It's the art of transformation. Tomorrow's cities will not simply survive the storms. They will learn from them. They will breathe with the tides, flow with the rivers, and, when needed, rebuild themselves stronger, wiser, and greener. The future belongs to cities that learn to bend, not break. If this vision inspired you, imagine what comes next. Like, share, and subscribe, because the HydroVerse is just beginning to unfold. Together, we'll explore the technologies reshaping how humanity and water coexist. Join the flow. Every drop counts, but only when we know where it goes. For the longest time, managing our water was a job for engineers and policymakers, happening in pipes and plants we never saw. But today, that's changing. From the faucet in your kitchen to the cloud, we the citizens are becoming part of the system. We're not just users anymore, we're sensors, data points, and most importantly, we're becoming decision makers. Welcome to the age of empowered water citizenship. Before you can change a habit, you have to see it. That's why cities all over the world are launching real-time water data dashboards. These are platforms where you and I can track our own consumption, spot leaks, and see how efficient we're being. Take Melbourne, for example. Every home with a smart meter sends hourly updates to a citywide network. If there's a sudden spike in usage, the system sends an alert straight to the homeowner's phone. You may have a leak. This awareness is a game changer. Since Melbourne launched its Smart Water app, water use per household has dropped by a massive 22% in Tel Aviv. They've turned it into a friendly competition. Gamified dashboards compare neighborhoods, showing leaderboards for the top water savers. Suddenly, every litre saved isn't just invisible, it's a visible act of community pride. A data point that sends a positive ripple across the entire city. Awareness transforms habits, and habits transform systems. It's not just about seeing the numbers, it's about connecting with them. Behavioral psychology has officially entered the world of water conservation. New apps and platforms use what are called nudges, subtle digital cues, to encourage us to save water. It's not about control, it's about connection. When we see our daily water use visualized not as boring numbers, but as relatable stories, we start to care more. In Barcelona, you might get a message saying, "You've just saved enough water to make 12 cups of coffee." In Cape Town, when the city faced a catastrophic drought, they created the Day Zero dashboard. It was a public countdown to the moment the taps would run dry. That countdown became a collective mission. The city survived, not just because of technology, but because people came together and changed their habits. That's the power of a shared story. When we talk about data, it's easy to think of surveillance. But in this new era, open data isn't about watching us. It's about building trust. Cities like Amsterdam, Singapore, and San Diego now publish transparent, real-time water reports online for everyone to see. Leaks, contamination alerts, usage peaks, it's all out in the open. You can even walk through a subway station and see live water data for your district on a public screen. This transparency creates accountability, not through punishment, but through pride. When a city trusts its citizens with the truth, citizens respond with care. We're seeing schools start water-saving challenges. Local businesses compete for water-smart certified badges. Neighborhoods are becoming living laboratories of collective responsibility. The data flows not as a tool of control, but as a source of shared awareness. We're now witnessing the rise of citizen-driven science. People aren't just consuming data anymore. We're creating it and training algorithms with it. Through apps like OpenHydro and Aquapulse, volunteers can upload local rainfall data, changes in water pressure, or even soil moisture levels from their own backyards. Every home becomes a sensor, and every citizen becomes a scientist. In India's flood-prone regions, Farmers text daily rainfall numbers to a cloud system. In return, an AI sends back personalized irrigation advice. It's a powerful feedback loop. Data goes up and insight comes down. This is where the line between government and citizen starts to blur. The government provides the tools, but the people generate the intelligence. But let's be clear, technology alone changes nothing unless our behavior follows. This is why behavioral economists and social designers are now working side by side with engineers. They're not just studying the flow of water. They're studying the flow of human motivation. What makes us care? What makes us act? In Los Angeles, digital water diaries let households manually log every use, turning water consumption into a mindfulness practice. In Tokyo, subway ads don't scold you. They celebrate you, displaying the total savings achieved that week together. We saved enough water to fill 200 Olympic pools. Public participation becomes a ritual, a shared narrative of responsibility. When conservation becomes part of our culture, data becomes part of our identity, and that identity is more powerful than any regulation. The future of water isn't just smart. It's social. Every small action, a shorter shower, a fixed leak, a bucket of water reused sends a ripple across a digital ocean of accountability. And when millions of those ripples align, they become a wave of transformation. It all starts with one drop, one choice, one app notification that says, "You just saved 3 liters." That's how we rebuild our world, one mindful action at a time. For centuries, cities have been places of memory, repositories of history, culture, and infrastructure. We build maps to remember where things are. But now we build living maps that remember how things behave. Welcome to the digital twin, the mirror city that knows itself. A digital twin is more than a model. It is a synchronized, dynamic replica of the physical city, fed by sensors, satellites, and human input. It doesn't merely depict, it lives. Pumps, valves, reservoirs, roofs, parks. Every element has a digital counterpart, updated in real time. The twin runs millions of simulations in seconds, answering the question engineers once feared: what if? In the past, planners relied on historical records and static maps. They guessed, they hoped. Digital twins change the game. They let us run tomorrow, today. What happens if a storm doubles in intensity? Which pumps fail first? Which neighborhoods lose pressure? By simulating outcomes, cities can choose interventions before the water rises. Rotterdam, a city that has long engineered its survival with dikes and canals, now pairs physical defenses with a digital twin. When tide and storm converge, the twin predicts pressure points and coordinates pumps, gates, and road closures automatically. The result: minutes saved, trillions in damage avoided, and lives protected. The greatest power of the twin is integration. Water is never alone. It is bound to energy, transport, land use, and people. A smart pump must know the sun's forecast, the grid's load, and the neighborhood's demand profile. The twin orchestrates all these variables, balancing supply with social need efficiently and ethically. One of the twin's most practical roles is predictive maintenance. Sensors whisper warnings long before failures become ruptures. Machine learning models within the twin detect patterns, subtle shifts in vibration or pressure that precede a burst. The city acts proactively, valves are preemptively replaced, drones are dispatched, supply is rerouted, human crisis averted. Digital twins are powerful tools, but their power must be balanced by ethics. Who owns the model? Who sees the data? Who decides priorities? The most successful twins are participatory, open dashboards, anonymized data, and citizen input loops. In such cities, people don't fear the mirror, they shape it. The twin of tomorrow is not monolithic. It is distributed, micro-twins live at the edge, each building, park, or bridge carrying its own digital self, communicating with the city's central brain. This architecture reduces latency, increases resilience, and preserves privacy. Decisions can be made locally in milliseconds. Swarms of microtwins will enable hyperlocal responses to floods, leaks, and contamination, a new choreography between machines and communities. The twin does not replace judgment, it informs it. When choices are hard, who receives water first? The twin can reveal outcomes, trade-offs, and social impacts. These insights allow policymakers to choose transparently and equitably. The technology becomes a moral compass, not a black box. Imagine a planet where twins speak to each other. Rotterdam shares surge strategies with Manila. Cape Town shares drought simulations with Los Angeles. Knowledge becomes a public good. Cities learn faster through a global mesh of experience. The twin network accelerates resilience, spreading what works and discarding what doesn't. A city that knows itself is a city that cares. The future grid with digital twins at its heart offers not domination, but partnership. We will not outsmart water. We will learn its language, anticipate its moods, and design our lives with humility. The twin is the map, the teacher, and the mirror. And in that reflection, we may finally see what we must become: caretakers of the systems that sustain us. If this chapter of HydroVerse inspired you, help the ripples spread. Join us next episode as we follow the threads between infrastructure, policy, and human choice. HydroVerse, where water, data, and humanity converge. Like the video, subscribe, and share, and tell us in the comments, what would your city's twin reveal about your water?